With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? Two students X and Y, they perform an experiment on a potentiometer separately using the circuit given. Now keeping other parameter unchanged, how will the position of the null point be affected? Okay. Now X is doing? X is increasing the value of the resistance R in the setup by keeping K1, key K1 closed and K2 open. Okay. So this K1 is closed and K2 is open. Okay. When this is the situation, what will happen? So the current which is coming here, okay, so it would be going into this part. Okay, it would be going into this loop, and this student is basically increasing this value of the resistance. So we can say that at this situation, I value of the current would be equals to E divided by this R plus R dash. Now what is the value? What is R dash? It is the length of this resistance of this portion. Okay, now this is R. So what would be the potential drop from A to B? What is the value of the potential drop A to B, VAB? This value would be equals to, we can find this value as, because the current here is I and the resistance is R dash, so we can say that VAB would be equals to I into R dash, or we can say that it would be equals to E into R dash divided by R plus R dash. This would be the value. Now what would be the potential gradient here? So we can say that our potential gradient is given as potential gradient. We can just say potential gradient would be equals to, or we can just say potential gradient as K. We can just take the value of potential gradient as K. It would be total voltage drop in the wire divided by the total length of the wire. So it would be E R dash divided by L times R plus R dash. Okay. Now for this portion, let's say this length from here to here, if this length is X, so what is this potential from A to J? What would be the potential? So we can say that VAJ would be equals to this potential gradient times which is K multiplied by X. So we can say that its value would be E R dash divided by L times R plus R dash. Okay, this would be the value. So we have put the value, so it would be multiplied by X. So this is the value. So what could be the value of now, since this is open, so there is no current here, so the potential difference across A to J would be equals to the EMF of this battery E. So we can say that VAJ, this is AJ, this would be equals to EMF of the cell. So from here our EMF would turn out to be, the value of X, we can calculate the value of X, and the value of X from here would turn out to be, this would turn out to be E is the EMF of the cell L, R plus R dash, okay, divided by E, we divide it by E, and then here we divided by R dash. Now what we are doing, student X is doing what? It is increasing R. So if we are increasing this value of R, if R is increased, we just write here. So what would be the value of X? X would be increased. Now that means he should shift this jockey to the B, towards B, or we can say that it should shift the jockey. So null point, we can just say null point moves towards right. Okay, now this is the first part. Now in the second part, what student Y is doing, he is decreasing the value of S in the setup. So it is decreasing this value. So let's say the current here is small I. Okay, now if this is the current, so what is the potential drop across these two ends of the wire if the current is I? So we can say that this value would be equals to, or we can say that this value would be same as this value, VAJ. So we can say that potential drop this would be equals to this value would be equals to, we can just, if we move into this loop, so it would be equals to E. We are moving from here to here. If you move into this loop, so here to here we are gaining potential, and here to here we are moving into the direction of current. So it would be E minus I into S. So we write the value as E minus I into S. Now what would be the total value of the current? Here we see that EMF is I, and the total resistance would be, so we just write minus I, this I in this current value. We need to write the value of current as I would be equals to E by total resistance. So S plus the resistance of the battery, S plus small r, this is the resistance of the battery small r, multiplied by S. Okay, so this would turn out to be E into S, the resistance, divided by battery resistance into S. Now this is the EMF. Now this would be the same potential drop, VAJ, and VAJ we have already calculated. VAJ would be equals to K into X. So we can say that this value would turn out to be we can say that this would be equals to Vaj. This would be equals to K into X. So we can say that it would be epsilon S, or we can say that EMF into S divided by R plus S. Now, if we are changing S, so K is independent of S. We can just see here, K is not dependent upon S. So we can just take it to be a constant, and we can just rewrite this as X would be equals to, we just rewrite as K R divided by S plus 1. Sorry, E R by S plus 1, and we just write K here. Now what will happen? What is he doing? So he is decreasing this value. So if this is decreased, now if if S is decreased, now what will happen? R by S would what? R by S would increase. And if R by S is increasing, so what would be this ratio? 1 divided by R by S plus 1. What would be this ratio be? So it would decrease. That means X would decrease. So we can say that X is decreasing. Now if X is decreasing, that means we should move, or we can say that null point moves towards left. It is moving towards left. So hope you have understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.